The robot sub is sent on multiple dives. No one can be sure how long it can stand the immense pressures of the deep. But for the geologist on board, this is a priceless opportunity to investigate exactly what the vents are made of. Controlled from the surface, the mechanical arm reaches out. The aim to collect a vent without damaging it. It's extremely delicate work. And remember, this is being managed at a distance of 3 miles. The controller has to extract the piece of chimney and then very carefully maneuver it into a collection basket. Mission accomplished. This is one of the rocks the robot sub has just brought back from the ocean floor. It's part of one of those hydrothermal chimneys we saw on the video. This is where the hot, dark water would have blasted out. Now, I'm wearing gloves because it turns out that hydrothermal vents are rich in minerals and metals, including cadmium and mercury. But most significant, take a look at this. Just inside these little tiny gold flecks, they're copper. And the fact that these vents are so rich in valuable metals has attracted a lot of attention. In the lab, the rocks lie glinting. They contain far more metal than any rocks on land. That's why mining companies are now looking at operations in the ocean. And the geologists here have been calculating how much ore is in this part of the seabed and what it could be worth.
If we had to assume that was all ore deposit, and there's no reason to suspect it's not, then that would give us a mass of mineral deposit here of about 4 million tons. Scenarios for copper content, 5–10%, we're talking billions of dollars worth of copper. If this was on land, this would be a really valuable deposit. Because it's not on land, it's underneath 5 kilometers of water, which makes it virtually inaccessible. Trying to access these as mining deposits would be a little bit akin to mining asteroids. We can see them, we can bring up samples, but to bring up economically viable amounts of mineral would be very difficult.
Now, no one is suggesting mining this area, the Cayman Trough. This expedition is about science, not prospecting. But the rich deposits on many parts of the ocean floor are definitely targets for exploitation, and pretty soon. This is the vision of a Canadian mining company, Nautilus Minerals. It plans to dig up the seabed off Papua New Guinea. Huge machines would break up the ocean floor, pulverize the rock, and pipe up the fragments. The operation was due to start this year. It's on hold because of a legal dispute, but the company is keen to start. And this is where the Nautilus animation becomes reality. Its first underwater mining machines are under construction at a plant in Newcastle in the northeast of England. When you see people beside them, you get a sense of their immense scale. The company argues that gouging out the seabed will be less destructive than mining on land.
The deposits sit above the seafloor, so we don't need to dig through mountains to get to them. And that means as well the high grades combined with not needing to remove a lot of material means that we've got the potential here to offer the world a mineral solution which has the potential to have a lot less waste.
Nothing could survive this great machine chewing along the seabed, could it?
Well, again, there's a number of strategies that that have been developed, again with a team of world-leading experts, to make sure that any impacts are minimized or mitigated against where possible. One of those strategies involves moving animals out of the path of mining and putting them in places where mining's already occurred. And in addition, we've committed to establishing artificial substrates to help the system recover. And studies, and again, there's over 7 years of study at the site. Studies have shown that we expect the system to recover within a few years, which is very quick.
So Nautilus believes it can mine the seabed and help life return afterwards. Obviously, there are plenty of people who question that. But the idea of exploiting the ocean floor is gaining ground. The mining machines are being built on Tyneside, once a key centre for British shipbuilding. It's valuable work. Deep sea mining could be big business, and the British government is among many promoting it. One British plan even got a personal push from the Prime Minister. The British arm of Lockheed Martin, the American defence giant, wants to vacuum pieces of rock called nodules. Unlike hydrothermal vents, nodules lie on vast areas of the ocean floor, and a race is on to secure the best access to them. The United Nations, through its International Seabed Authority, sells licenses for exploration, for nodules and hydrothermal vents. A dozen so far, the majority in the Pacific, south of Hawaii. China, Russia, South Korea, France and Belgium are among the countries to buy them. We're now on the brink of seeing if mining will actually happen.
I think the biggest uncertainties for seabed mining are firstly that nobody has yet done this at a commercial scale. People have tested technology, but that is very different from operating at a full commercial scale. Secondly, we do not fully understand the consequences for the marine environment of operating a mine over a prolonged period of in excess of 10 years.
So no one can be sure of the impact of mining because it hasn't yet started. The International Seabed Authority is working on a set of rules designed to minimize the damage. What are you going to try and do in terms of protecting the environment? What are you looking for?
There will always be some impact from mining, whether it's on land or at the bottom of the sea. It's impossible to mine without creating some sort of environmental impact. What we need to do is to understand the scale of that impact. We need to understand the consequences, the time that environmental damage will take place, and whether there is any knock-on impact, for example, on other parts of the ocean or indeed on coastal states.
Back on board the James Cook, there's a real debate about mining. The scientists argue among themselves about the rights and wrongs. Overshadowing everything are questions about the destruction of marine life and whether mining is even feasible.
This material is not like oil, it's not like gas, it's extremely corrosive, it's very abrasive, it's going to destroy pumps, it's going to destroy pipes, it's going to be very, very difficult to lift that material to the surface. And then of course, the engineering and geology aside, we mustn't lose sight of the fact that these deposits are oases of exotic life, and we have to be very careful that in our attempt to exploit perhaps what might be a mineral resource, we don't trample a more valuable resource, which is the biological one, which we know so very little about.
The biological cost is the animals living there are endemic. They don't live anywhere else. That is their home, and they've adapted over many millions of years to live there. If you wipe out that area by mining, those animals have to do one of two things. They disperse and they colonize another hydrothermal vent somewhere, or they die. And what happens when they die is the vent will become biologically extinct.
At the heart of this argument is a fundamental question about our attitude to the oceans, whether we think they deserve special protection or whether their riches should be exploited like any other part of the planet.
If society wants these metals, maintains this demand, wants technologies, then we have to be prepared to recover these metals from wherever we find them to some extent. You know, we can't. I'm not sure we can simply corral areas of Earth resources off and say they're non-accessible.
I don't think we particularly own the deep ocean in the sense that we can do what we like to it. Instead, we share responsibility for its stewardship. And the more people can see what's down there and share in that discovery with us, then we can all start thinking deep for the future.
This scientist, Rachel Mills, thinks that as consumers, we all need to confront this question. It's our demands that have fueled the search for new resources in the first place. She's carried out research for the mining company Nautilus and believes no one should avoid thinking about this.
Everything we have, from the watches you're wearing, the jewelry we wear, the clothes we wear, everything we're surrounded by, the way we live, relies on mineral resources. Okay? We don't often ask us where they come from. We don't often ask whether those mining companies are mining sustainably, where they're mining at present. So I think actually the debate needs to be much bigger, and we need to think about whether there is sustainable mining on land, whether there's sustainable mining in the shelf seas, or whether there's sustainable mining in the deep seas. There's a lot of questions, but they're the same whether you are in the deep sea or on land.
Our time on the James Cook leaves two impressions. First, that the moment of discovery created a real buzz on board. We're all thrilled by exploration. Second, that the more we know about the ocean, the more likely we are to exploit it. I'm sure mining of the seabed will happen. The question is whether it'll be managed to limit the impact or become a devastating free-for-all. The next few years will decide the outcome.